Welcome back. In today's lesson, we're going to continue looking at the properties of the atmosphere. We're going to look at how wind forms, how wind blows, and how the wind, along with water, will create our weather. So let's look at some examples. So wind is when air molecules are piled up in high concentration. They will act like a spring and spring away from the high concentration towards the low concentration. So wind is always air that's moving from high pressure to low pressure. Okay, that's the movement of these molecules. So what happens is a lot of times you're going to get currents of air or movements of air or wind blowing in the atmosphere based upon when something is in high concentration and when is it in low. When is it high pressure gas and when is it low pressure gas? So let me give you a simple scenario here. The ground where the sun is shining is very warm, and that means that heat is being given or bumped into the air above the ground. So the ground is warming the air above it. When that happens, that warm air is less dense than the cold air. So the warm air rises. All right, now you have to get this in your mind. When it rises, that was the air that was at the ground. Now it's bunched up higher in the sky. So what looks here as a cloud is essentially high concentration of air, because the air that used to be in the sky is still there, and the air that used to be on the ground is now in the sky because it's risen because of the heat. The hot rocks are heating the air rises. Okay? So that means there's a high concentration in the cloud. And so it moves away from the cloud. High concentration always goes away. Well, the higher it is in the air, the colder it is. So that warm air is starting to cool off. As it cools off, it sinks. Okay? So as it's sinking, it's going to be moving from high concentration to low. Well, where is there a low concentration? The low concentration is where the air used to be above the hot rocks. The air that used to be of the hot rocks is now gone, and so it's left a hole. That's a low concentration. So air is going to blow from the high, which is in the air, higher in the air, down towards the ground, and you're going to get a current of air. So this is how the wind blows. The higher you are in altitude, the higher the wind speed. So for instance, the jet stream is very high altitude winds. This would be much, much higher. So depending upon whether you're at ground level or high, sometimes the wind will blow severely. You see this in turbulence in airplanes, where you get bursts or gusts of winds at these high altitudes. Now, you can kind of see that we're heading towards weather, because we're talking about temperature, we're talking about wind, and we're talking about water. So that is all the components, that's all the ingredients you need for weather, is warm and cold, dry and wet, and a movement around of this through the winds, through pressure differences. So we need to talk about humidity. Humidity is the amount of water that an air mass can hold. Okay? So if it's more humid, it's holding more water. If it's less humid or dry, it's holding less water. And relative humidity is the amount of water that it's holding based upon how much it can hold. Okay? So for instance, let's imagine, I put a sponge here as a picture. If you have warm air, it can hold a lot of water. So think of the sponge as being bigger. Okay? If you have cooler air, it can't hold as much water. The warmer the air, the more water it can hold. So I think of this cooler air as having a smaller sponge. And then the cold air is even a smaller sponge. So let's say you have the same amount of water in each of these three airs. Let's look at the 10 degrees. I have that much water in the 10 degrees, and the sponge is exactly as big as that water. Okay, that yellow basically went right around that water circle, and it can hold that much, and it's got that much. That means it's holding every bit of water that it can hold, so it's holding 100% of the water that it can hold. That's called 100% relative humidity. Okay? Normally when air reaches 100% relative humidity, it will precipitate. It will snow, it will sleet, it will rain, it will something. It will fall out somehow, okay? Now let's imagine that we're warmer. So now from 10 degrees have gone up to 20 degrees. The air can hold more water at 20 degrees, so think of it as a bigger sponge. I have the same amount of water I had a minute ago, but I had more of a sponge. The air can hold more water if it needed to. So the water vapor that it's holding is not 100% now, it's only 53% because the sponge is bigger, because the temperature is bigger. If you had very warm air, then you can hold tons of water, and if I had that same amount of water, I may only have 28% relative humidity on a hot day, but 100% relative humidity on a cold day. Winter is a much drier season than summer. Summer, there's more moisture because the air is warmer, can hold more. So that same amount of water might snow at Christmas at 10 degrees, but not do anything except be sticky on a summer day, not rain at all. Okay, here's a concept called latent heat. If you were to scald yourself on boiling water, and then later in your life, burn yourself on steam, both of those were 100 degrees. The boiling water is 100 degrees, steam is also 100 degrees. But the burn that you would get on your arm is worse when you burn yourself with steam because it has more energy in it. Because if you look at this graph, as energy goes from left to right, temperature goes higher. In order to melt ice, you're going to have to add energy without changing its temperature. So ice, solid ice at 0 is solid, but liquid water can go all the way to 0. So it takes energy just to melt the ice without changing its temperature. Likewise, to boil water from liquid to a gas requires a lot of energy. It absorbs energy without changing its temperature. Okay, so latent heat is the extra thermal energy, say, in the steam that burns you worse, because that steam had latent heat in it. It had heat, extra thermal energy that didn't change its temperature. So it was still 100 degrees, just same as the water, but it had more energy in it, so it had more latent heat in it. And then finally, when is something going to condense? Okay, so as the warm air goes higher in the sky and it is holding water, it's holding moisture, the temperature starts dropping. Okay, so remember what's happening. The bigger the sponge is when it's hotter. The smaller the sponge is when it's colder. So as that air that has water in it is rising higher, what'll happen is that the sponge is getting smaller, smaller, smaller. Eventually, that amount of water that it's holding becomes 100%. As soon as it becomes 100%, that's called condensation, and you will see a cloud. So water vapor in the air is in the air without a cloud, and then as the water vapor goes higher in the sky, it will start turning into a white cloud that you can see those water vapor because it's going to go from gas to liquid. And so when you see white clouds, you're actually looking at liquid water hanging out in the air. And so you're going to see that the condensation, it will condense at a certain temperature based upon the amount of water that's in the air.